Hello everyone and welcome to today's SANS webcast, The Magic of Raw Data Carving. My name is Carol Auth of the SANS Institute and I will be moderating today's webcast. Today's featured speaker is Kevin Ripa, SANS Community Instructor. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Kevin.
Well, good morning and thank you. Welcome to everybody that's joining us. Depending where you're from, it could potentially be quite early in the morning. So I appreciate you setting the time aside and coming and listening. I'm not much big on introductions. They're in the slide deck. I own a company or two. I'm on LinkedIn, on Twitter, been around for some time. Our forensics lab here, probably one of the only ones that I'm aware of, at least in Canada, with a Class 100 data recovery lab as part of our structure. So that allows us to do repairs on hard drives in case we get something in that's busted and you can't access the hard drive. I teach for SANS 301, Security 301 or 401, and the Forensics 500. And if you're interested in some reading material because you can't sleep, my CV is online at that link. For now, everything we're going to talk about today is present and accurate at the time that we're talking about it. May change tomorrow. You never know. Now, today we're going to be talking about raw data rebuilding, and what do we mean by that? Well, there's a lot of tools that we use to go out into a forensic image and extract data. And we rely on these tools far too much as far as I'm concerned. And in a lot of cases, we don't know what they're missing. Well, today I'm going to show you a couple of shining examples of what you're missing. And if you've been doing forensics for 10 minutes, you're going to look at these examples and automatically you're going to have that, oh, snap moment, because you know now that you have missed stuff. So this is one of those disciplines where you can't be like you are everywhere else in your lab. And you know, we all know what it's like. You're so busy that it's difficult to find the time to practice and learn stuff. And so usually when we find a need, we jump in and we spend 10 or 15 minutes on a bit of research and we figure out how to do something. Well, this is one of those disciplines where that's just not going to work. You have to have a familiarity with files, file headers, file structure ahead of time. You need to be able to see files in hex, in unallocated space, and be able to recognize to some degree what you might be looking at. And then you got to practice it. That's the only way to get good at it. It is so easy to get dragged down the rabbit hole doing this stuff that if you're trying to learn it during an investigation, you're going to lose 2 days. And I mean, trying to do this stuff is like gaming. You wake up in the morning, you start a game, and next time you look out the window, the sun is setting, and you don't know where the day has gone. This is very much like that, at least for me anyway. So why do we want to data carve? I said there's tools out there, there's carving tools. All of your 800-pound gorillas all have their own built-in carving tools, whichever ones you use, if you use them. And it isn't to say that these carvers aren't capable. PhotoRec is a great carver, and I suspect that maybe a lot of listeners use PhotoRec. We're going to look at that today, and we're going to see some of the shortcomings of even something as robust as PhotoRec. Basically, when you're recovering data that's been deleted, you're looking for, or the carver is looking for intact data. When you tell the carver to go out and get, say, all the Word docs, for example, that's not really raw data rebuilding or raw data carving. It's a program going and finding something based on a set of parameters and dragging it out. Well, that's great, and there's nothing wrong with that. However, you need to understand your limitations. You need to understand that you're pushing buttons. That's all you're doing. And you're only going to recover, for the most part, intact files. In other words, somebody deleted a Word document and you sent the carver out to go find all the Word documents. It's going to look for a file header, and we're going to look at one of those in a second. It's going to go look out for an office style header, file header, and it's going to start scraping, and it's going to grab data until it finds the end of the footer. And then it's going to grab that data and it's going to save it out to somewhere so that you can go back and look at it later. Nothing wrong with this. Problem is, though, if there is something wrong with the code, maybe it's fragmented, or new data has been written in the middle of the old Word document or something like that, it's going to carve and it may never find the footer. And if it doesn't find the footer, you're going to get chunks of data and that don't make any sense, and the file's not going to open. And you're not going to know why, and you're not going to know what to do with it. Not to mention the fact that what if the header is overwritten? The carving tool is not going to find that document now, and you'll never know what you missed. So we need to consider things like that. So where would this raw data rebuilding come into place? What happens if you don't have a viable master file table? So you can't, if you're used to running NCase, for example, you can't run a recover folders. It's without an MFT, it's not going to see a lot of the stuff that it should see. It could be fragmented. It could be overwritten. You don't know. Raw data carving is going into this space basically with a hex editor and looking for it. Now, this is not something that you're going to use all the time. But when you need to find something, this is the best way to find it. Let's look at how it's currently being done. You're going to go out there, you're going to run a carving tool, you're going to try to recover whatever your parameters say, Word documents, spreadsheets, PDFs, photographs, whatever. And this carving tool is going to go out and start carving. And you're going to sit there for hours, if not days. And when you come back, when the carving is done, you're going to see many, many folders full of stuff. And you're not going to have file names. You're just going to have numbers. And you're going to have, 20,000 Word documents in a folder. Now what do you do? Well, you're going to do what anybody who's done this for 15 minutes always does. You're going to double click, and it's going to open or it's not. And you're going to look at it. Is this relevant? No. And you're going to move on to the second one, and then the third one, and then the fourth one, because that's the way we've always done it. This is not a good application of your time. In many, many cases, we know what we're looking for. It's just a case of finding it. So we could, instead of using the carving tool, wasting a bunch of time, trying to open a file that gives you an error and says you can't open it, so now you just go on to the next one, which is a mistake, and we're going to find out why in a second. How about you apply your search terms? Let your search terms work for you. If you have a fragmented file where the file header has been overwritten, and you go to carve, you're never going to find it. It's just never going to show up, and you're never going to know it's there. But what if the header was overwritten, but the rest of the file still existed? If you ran a search term search, it would hit on the search term in the file. Now you can go and look and see that hit. Now comes the question of, how do we massage that data out of there and build it so that the client can look at it and see what we found? And now you're starting to see why we might want to do this. And I'm going to show you some examples and some different types of files, and we're going to look at that. So what are we going to use to do this? Well, the tools, fortunately, are pretty simple. If you want to practice, you just need a bunch of file types. Where am I going to get those? Off of your own computer. It's full of files. If you want to know what a Word document looks in a Hex Editor, take a known good Word document, dump it into a Hex Editor. Now you know what it looks like. A photograph, a whatever. You need a good Hex Editor. I personally like 010. Ultra Edit's also good. WinHex is fantastic. It just doesn't matter. What you need to be able to do, though, and understand the limitations of some of the free hex editors. Some of the free hex editors will allow you to view the hex, but will not allow you to edit the hex. And we're going to need one that allows us to edit hex. The most important tool in your toolbox, obviously, is your brain, not the buttons in your 800-pound gorilla forensic suite. You have to know what the data looks like in the raw. So we're going to look at some of that stuff and what that code looks like. Again, as I said, most files, pretty much all of them, have headers and footers or file signatures. Some of them don't have any. Text files don't have any. Old school emails and some current emails don't have any. So how are you going to carve? If you look back with the old DVX files and let's say Outlook Express days, if those emails were deleted, how are you going to carve for them? There's no file header, no file footer. They're text files. The only way you were going to do that was with search terms and then learning where the beginning and the end of that particular email was and carve it out. So let's look at some of these file signatures. I would suggest that if you're comfortable living in Hex, you can look at it as a Hex representation. But I know when I first started out, I wasn't comfortable looking at Hex, and a lot of people aren't. So let's look at it the way that the Hex editor presents it on the text side of things. And so, for example, Office documents pre-2007, you can see that the ASCII representation has that funny looking D and the funny looking I. And the way I used to remember that was, oh, it's D-I-E-I-O. It's just what I'd call it. Yes, it's stupid, whatever. Let's look at the Hex side of things, especially for the Office documents pre-2007. I want you to look carefully at that hex, D0CF11E0. Let's be creative and look at that. What does it spell? Doc file. How cool is that? That's pretty neat. Anyway, if you never noticed that before, kind of cool to see that. 2007 and later, they changed their format, and it was everything is XML files in kind of a zip file style of construction. So in other words, when you open these up in Hex Editor, you don't actually get to see the text of the file. More on that later. PDF documents are going to start out %PDF, and their footer is %EOF for end of file. JPEG files, I always remember that as YOYA, and that YOYA is usually followed up with JFIF in capital letters, and we'll see examples of all of this in the Hex representation. FFD8, FFE0. We're certainly not going to cover all the file signatures that are available to us, but these are some of the most common ones that you're going to see. So we have some HTML, MP3s, some video files here. So we can stare at that all day long, or we can just go ahead and do it. So we're going to move along here. I'm hoping that everybody can see the Hex editor here. If they can't, just somebody leave a comment and I'll try to blow it up. But I think everybody should be able to see it all right. So one of the first things I'm going to do, like I say, I like to use 010 as my Hex editor, and you need an image to work with, or your evidence, whatever you're going to do. And what I want to do first is I want to show you what happens when we use a normal file carver. So I'm sure many of you have used PhotoRec, and if you haven't, no big deal. You're going to see us use it here. So we're going to point PhotoRec at an image that I have mounted already. And we're picking our file system. We're going to scan the whole thing. It's just a very small image, so it's not going to take long to scan it. I'm going to just throw it on my desktop here. And we're going to do our search. This search happens really, really quickly. And what we've basically found on this image, now this image, I had taken an image and I basically trashed the MFT. There's no MFT on this at all. And so what PhotoRec did for us was it carved out a Word doc, some Word docs, PDFs, JPEGs, a couple of text files. Let's go see what it found. So these were the files that it found. And one of the interesting things here is that it said it found a text file, and yet I don't see a text file here anywhere. I see a couple of Java files. I don't know what's going on with them. Some Word documents. So now what we can do is, if we've got our Hex Editor, we can just grab files and drag them in and have a peek at them. So for example, I've got to get out of administrator mode. By the way, most Hex Editors, if you're going to use them to look at a physical drive, you have to be running them as administrator. So in a case like this, I look at this, I dragged it into a Hex Editor. It was a Java file. So if I had gone and tried to open it up, it's going to ask me, how do you want to open this? Well, I don't know. How many people know how to open a Java file? Well, obviously, there's going to be people that do, but you know, this brings up some of its own problems. So if I drag it over to a Hex Editor, I can kind of see the content here, and I can even see a little bit of text. I've got some stuff in here, but you know, when I look at this, experience tells me this is looking a whole lot like HTML. So how about if I go back here and, just for giggles, I change it to HTML. I try to open it. There's a whole message. Well, oddly enough, it's just a fragment. Your carver of choice, you saw the PhotoRec, didn't grab it properly. Let's look at something different. Here's another Java file. What's in here? So we've got another one. Well, this one's a whole lot longer. Wonder what happened here. Let's try this one. Now again, this is a fragment. HTML is quite forgiving in terms of being able to pick up wherever. So now we've got an entire email here. And we've been able to pull this out. Look at this whole email. It's not the way it was that when the user saw it, because there's pieces missing. You wouldn't have, you know, unless you know what to do with this, you wouldn't have found this. And this is kind of the key, kind of what I'm talking about here. So now let's close this and let's look at something a little bit differently. Now I'm going to show you an easy carve, and then we're going to get into rebuilding pieces of carving. So the first thing I want to do is I'm going to mount a drive, and I'm going to go search it. So this is an entire hard drive, an entire working hard drive that would boot. We're going to do something really easy here, and just in the interest of time, I'm not just going to run the whole search from scratch. So let's say we're going to do a search on something, and I'm going to search the term YRTL. That's my search term. Don't judge. So we run it, we do the search, and lo and behold, it finds our search term YRTL. Now in this particular case, there's nothing wrong with this file. The reason I'm showing it to you is so that you can see what happens with a file that's not broken. Okay? So I'm going to look for a header, I'm going to look for a footer. This is really easy because the header, which starts right here, and this is the header for a web page, always starts _HTML. This header is easy to identify. There's nothing before it. That is not always the case. If I have a file that ends at the end of a sector boundary, the next file starts at the beginning of the next sector, this is going to be hard to see because there's material right up to here. Okay, so sometimes it's easy to see, sometimes it's not. I'm using this example because it's easy to see. Now I'm going to start to sweep it. And you can sweep this with a mouse. I recommend hold down the Shift key and your down arrow. However, if it's a big, long file, you might want to page down while you're holding down the Shift key. This is relatively short, so I'm just going to scan it like this so you can get a visual sense of what's going on. So we look until we find an interruption of what we're carving, what we're scraping. You know visually while you're watching it that something changed, because all of a sudden we've got all of this wide open space. So again, really easy one. I can see the footer. The footer in an HTML file is /HTML. So I know I've got the end of the file. As you do this more and as you get comfortable with it, you can sweep really, really fast. And even though you can't read specifically what you're seeing because it's sweeping by so fast, you're going to notice changes in that text. And that's when you stop sweeping and you back up a bit to see what's going on. In any case, we didn't have to do that here because we've got a really simple file. So what can we do with this? Well, I'm going to grab this and I'm going to save it out. What am I going to save it out to? Well, we know it's a web page, an HTML file. So I'm just going to go draft one, and I'm going to save it with the extension that I want to save it with. And then we're going to go over and we're going to see what we ended up with. There's our file. What we did was we just carved out an email. In this particular case, pretty important email. Changed the names and the dates, but this came from an actual case that was, this email was critical. So that gives you a sense of what that looks like. Now let's look at something that's not so simple. What happens if you get a file and you don't know what to do with that file? So in this particular case, we're going to talk about a .epp file. What is a .epp file? Most people are not going to know. If you're a photographer, you're going to know. That's a proprietary file format for Canon cameras. So what can we do with this? Well, we can try to open it. It's not going to open. So a lot of examiners have programs like IrfanView, probably one of the most robust image viewing programs out there. So they're going to go and they're going to throw it into IrfanView. Yeah, IrfanView can't read it either. Here's another issue that you have. If you're doing forensics, you're probably doing it on a machine that's isolated from the network, or you should be. And so if you're doing that, what are you going to do? You're going to run to another machine and you're going to try to figure out what kind of program you could download to view an EPP file. You may be successful, you may not. What are you going to do? Download 2 or 3, run them over to your forensic computer, install them, hope they work. What if they don't? What if they've got spyware? You start to see a lot of the problems here. So if you can manage this manually, you're doing way better than the average person. So let's take this EPP file and let's throw it in our Hex Editor. So we immediately see our file signature here. And again, if you can't see the hex that I'm going through, let me know and I'll blow it up a little bit. It just goes easier and faster if I don't blow it up, but obviously if you can't see it, then it's useless. When we look at the hex, we start to see other information. Image 0639.jpg. Well, why didn't my file carver drag out a JPG? Because this is an intact file, and the places in this file where the actual JPEG sits do not necessarily land on sector boundaries. So let's look at this a little further. We can see, yeah, Canon EOS Digital Rebel, that's the name of the camera. We've got some metadata here. We're not going to concern ourselves with that because this isn't a metadata class. But anyway, the goal here is we want to open this picture, and I want to know what's in this picture. So let's start looking down this file. We know it's a picture. We even saw a file name there that said JPEG. So let's look for a signature that looks anything like a JPEG. So as we're sweeping, we're seeing changes in how this appears visually to our eyes. And all of a sudden we see Yoya, or on the hex side, FFD8. So what I want to do is I need to make that my file header. How do I do that? Simple. Let's just sweep up and let's just delete all of this other stuff. Now, before you do this, there's one step we have to do that's very, very important. Don't work with your original. Let's work with a copy. Why? We're altering this. If we actually pull evidence out of this, we still need that original to be able to let somebody else figure out what we did. So let's go back to where we were. And we're going to get rid of all of this stuff before Yoya. We want to make Yoya the beginning of our file so that the computer is using something that will open a JPEG. So delete up to there. We can see now that we've gotten rid of all of the hex before this, and this is all we have. Let's save that out. We'll call this draft1.jpg because that's the kind of file we're looking for. And what happens? Success. We have a little picture. Here's our problem. Very difficult to identify what's in that picture because it's so small. Besides which, I happen to know from the file that I carved that it should be a 2 megabyte picture. That little thing did not look like a 2 megabyte picture. Anybody that's looked at stuff like this long enough looked at that and said, hey, that looks very much like a thumbnail. Well, guess what? Large format photos and many other ones have the thumbnail embedded right into the picture, like it was in this case. So I want to see the bigger picture. Unfortunately, the computer's not going to show it to me because it's only reading from here and it's looking for a footer. So let's look for that footer. This YU is a JPEG footer, okay? But what did we just see here? Another Yoya. Wait a minute. Could right up to here be our thumbnail? I don't know. Let's have a look. What did we do last time to open the file with a we want to see? We got rid of everything that said in front of what we wanted to work with. So now we've moved this up to the front. But you notice it's not really Yoya, it's Yuya. And when we look at the hex, FFD9 instead of FFD8. Well, okay, but you know what? A lot of the stuff that you're going to do when it comes to file carving, in the raw data carving, is trial and error. That's why you never work with the original copy or one copy, because you're making changes. And maybe the changes you make aren't going to work, and you need to go back to where you left off and try something different. Trial and error. This is not going to work 100% of the time. But I'm going to show you examples where you are absolutely going to think to yourself, oh my gosh, what did I miss in all of those other cases I worked based on what I just saw? So it doesn't hurt to try. Let's see what happens. We're going to save this out. We're going to call this one draft 2. Let's try to open it. Ah, we got nothing. Well, let's take our handy dandy Irfan view or our viewer of choice. No, it didn't like that. What might be wrong with this? This is FFD9. The computer's looking for FFD8. Why don't we just try to change that? What's the worst that could happen? So let's go in here and change it to D8. Notice now it says Yoya. Let's save that out. Draft 3. Success. Now look at the success we have here. Who knows? I'm not a really good storyteller, so I can't concoct the story on the fly. But you know, what if this was a picture and you needed an address? You caught this picture off a phone or something like that, and you're starting to pull the thread. Well, now we've got an address off of this house. We've got material on recycle bins. Maybe we could blow this up and have a look at this license plate. We know they're probably military supporters because of these rings on the back of the tailgate. If we got those rings and they're military supporters, guess what? There may be firearms on premises. All these kinds of things that are going through your head to think about. So we've got an intact picture now. We've got something to work with. What if it's not intact? Well, let's look particularly in this picture, what's going to happen if it's not intact. let's go, I don't know, let's just pretend that something stomped all over the end of the picture. And I'm just going to grab a whole bunch of picture here. I think you'll agree I grabbed a whole bunch of picture. And I'm just going to delete that. Gone. Let's see what that looks like. Wow, we still got the picture, but if you look at the bottom here, on the left-hand side, you can't really see it because it's just lawn and lawn. But against the car, you're seeing that the bottom slice is out of place. There's a bunch of picture missing here. Not a big deal, but understand that if, and we've all seen them, when you recovered pictures, they looked like half the picture was missing. That's why. Data has stomped on some of it. Well, yeah, but that's the end of the picture. Okay, well, let's try something different. Let's go back to our draft 3 that we know is intact, and let's say something stomped on the front end of it. I don't know, let's take a sector or two, whatever. And let's delete that. Now what are you going to do with that? I don't even need to save that out for you to know that it's not going to open. There's nothing here to tell the computer what to open it with. Okay, but in the interest of our demo, the draft 5. And of course, like we thought, it's not going to open. If you get something like this, now you might say to yourself, well, how would I even identify that as a picture? There could be metadata in this picture somewhere that has the Canon stamp on it. So if your search term is Canon EOS or digital or something like that, something that tags in metadata in here, now you're tagging the metadata, not the actual non-ASCII code that's making the photo. But what, is there anything we could do with this? Well, how about if we took a known good picture and we grabbed the header from the known good picture? Let's give this a try. Let's go down to, let's just grab some of the header. Now, what I'm going to grab, I'm just grabbing this. Experience tells me I should grab this much. Maybe you don't want to grab that much. Maybe you're nervous, so you're just going to grab, let's grab the first row because I don't know what else to grab. So what we need to make sure of is look at how big the sweep is that we just did. We grabbed 16 bytes of data. Why is that important? Because when we come here, if we just try to paste it in there, it doesn't actually it pastes on top of stuff. Well, we don't want to overwrite stuff because we're already missing enough stuff. So we have to tell the Hex Editor to give us that space. So I just turned the clock back here. And now what I'm going to do is I'm going to insert the range of space that we need. So I'm going to insert bytes. How many did we say? 16. So we inserted 16 bytes. Now we have to put our data on top of those 16 bytes, that header. So we paste that in there. There's that Yoya JFIF that we got from this file right here. So let's save this out. Draft 6. No love, doesn't open. So that's fine. Let's go back here and let's just go back to where we were, which was right there. Let's go grab from that known good a bunch more stuff. And just keep trying. Keep trying to figure out how much of that you need. And you know what? You could try for an hour and maybe it won't work. But you could try for a few minutes and maybe it does. And if the evidence is that important, it's going to make all the difference in the world. So I'm going to grab this up to here. Why did I pick that? Only because all of this stuff that I just swept visually looks different than the stuff after it. I don't know why. So I don't know what that means, but I think that's a good place to look. So the first thing I'm going to do is make a note at the bottom in my Hex Editor. I get 640 bytes of data. So I'm going to copy that now. Go back to my original. Remember, I don't want to overwrite stuff, so I'm going to insert 640 bytes. Just did that, and now I'm going to paste the stuff I swept in there. Let's save that out. Success. Now, is this perfect? No, it's not perfect, but it's certainly better than what we had. We still have the address of the house now. We still can make out the material on the back of the truck. It's just not pristine, but it's better than a shot in the head with a frozen squirrel. So we're going to take it. It's better than what we had before. So that's a great example of manipulating something to maximize our return on what we found. So let's try something different. Let's change gears here. That was great. That was pictures. But what about Word documents? So with Word documents, first thing we're going to do is we're going to look at .doc, and we've got a good file. Now I say wire transfer info. Why? Oh, I don't know. Just to make it interesting, we're doing an embezzlement case or something ridiculous like that. I don't know. Somebody's hiding money. So this is our smoking gun file, and it works. It's a great working file. But what happens if the file's busted? How many people listening to this today have seen this? If you have carved for more than 5 minutes, you've had this happen. You've got a folder, you've got 500 Word documents in it that your carving tool found for you, and now you're going through them one at a time to see what opens, see what works. And you get this, it doesn't work. So what do? You close it and you go to the next one. Wait a minute. Don't be so quick. Let's try something different. Let's look at it in a Hex Editor. Here's our DIEIO. We know it's an office file. Scroll down. Wait a minute. Look at what we've got. We've got text. In .doc, .xls, .ppt, all of our text is in plain text in the document. Now, we could carve that out, and it'll look like a bit of a mess, but hey, it's better than nothing. How about when that happens, let's change it. Let's change the way we open this. Let's make it a text file. Why? Because that's really what we're after. And let's open it and see what happens. Look at that. It even kept some of the formatting. Now, there's all of this garbage here because it's a broken file, but we're not that interested in that. Here's our important stuff. So we went from a file that would not open, that many of you in the past have probably opened up this Word document. It failed. You said, okay, and you went to the next one. Look what you missed. There should be probably at least a few people having a bit of an oh snap moment right now. So what about docx? You're sitting there going, great, Kevin. Wow, .doc. You're sure a smart guy. But how many people use that anymore? And that was an easy one. Well, I'll tell you what, a lot of people do still use .doc. Your grandparents are probably still using it. Some of you, your parents are probably still using it. If you're doing forensics, I promise you, you are still coming across the old style format. But, okay, I hear your concerns. Let's do the docx. So we've got a docx, normal docx. It opens, it's just fine, nothing wrong with it. What about one that's broken? Error message. Now, at least in this case with docx, Office tries to offer you an opportunity to recover at least some of the contents. So let's say, yes, of course, you're going to help me out. I want to see it. No, nothing. It got me nothing. So we've got a broken docx. Well, in the past, many of us have probably just closed this and gone to the next one because that's what we know to do. Now, think about the difference here. We have just carved a whole bunch of docx files. Maybe we've got 1,000 of them. Maybe we've only got 500. But you've got to open up each one and check it for content. And when you get those error messages, you don't know if it had what you needed. You just think it's broken. You move on to the next one. So how can we minimize what we need to look for? Some of the 800-pound gorillas will parse even unallocated, based on the proprietary style of the file. So you can, in many cases, still do search term searching against material. And let's put this in here. Here's a docx. Nowhere in here do you see the text of a message. But a lot of the different, the bigger forensic suites will allow you to search in that proprietary format. I don't want to market for anybody, so I'm not going to throw a name out there, but I know specifically Outlook files, for example, PST files. When they're deleted, you can still search even though they look like this. So what do we do with this? Well, we can see by this PK, for anybody that's familiar with file signatures at all, you know that PK, you're most commonly going to see that in zip files, for example. Well, wait a minute. This file didn't open. We know it didn't open. We threw it in a hex editor, and it doesn't really look like a whole lot of anything. But we get this PK file signature. I wonder what would happen if we went in here and changed it to zip. Now, before I show you what's going to happen with that, let's take a normal one. We know that this is a working file. Always look at a working file so that you know what you should expect to see. So I've turned that into zip. Wow, it opened up just like a zip container, and now there's stuff in it. Now you can go through each one of these. These are all of the components that make that Word document a proper, viewable Word document. Let's go into the Word folder, and let's look at one of the biggest ones, document.xml. If you double click on that, chances are it's going to open up in your browser, which is not a bad place for it to open, because when it opens in your browser, you get to see it with different contrasting colors, so it makes the data more viewable. Now, also, there's more data in here. For example, this information here, stuff like this, these weird hex characters, you're going to see these throughout Word Office documents, whether they be spreadsheets or whatever. These are incredibly important because these can help determine how a file was created. This can prove, was this a new file that was created? Was it an old file that we save as and just change stuff inside? When you go save as, these values change, and they help you determine how was this file created. And we've done many, many cases where we've been able to show the genesis of a file rather than, you know, the story was somebody fabricated this file. And we know that the activity should have happened 6 months ago, but yet this file was created a week ago. So how could that have happened? Well, the assumption is going to be that, well, maybe they did this, or maybe they opened up another file and they, you know, created a new one or a save as. There's values in these documents through these hexes that will show you when that happened. And there's more and more research being done on this, and our lab is doing more research on this. But anyway, that's a webinar for another day. My point is that this is pretty easy to visually see, and we can see now the contents of our Word document in this XML. This is all stuff that was in our XML, international wires, Bank of New York. We've got all of the information. So now what happens in the case of our broken file? Well, we change it to zip, open it up. If it does not open up, that means that it's so damaged that even your zip program can't open this. Now, right now, I'm using 7-zip. I highly recommend 7-zip as your tool of choice for zip files over WinZip or the Windows compression utility. I can tell you that if I was using normal WinZip, this would not have opened. It's broken too badly to open. But 7-zip somehow looks at it differently and says, yeah, I'll open at least a little bit. So it did. And you notice that from the other file that we just opened, there's a lot less in here. We've got a Word folder. That's it. And when we open that, we've got this document.xml, and that's it. But when we open the document.xml, look at this. We still have the contents of the document, even though it won't open because the structure of the file is broken. Structure's broken, content is still there. You still have the evidence. When normally it would have thrown an error and you'd have just gone on to the next one. So we can get that data out of there, but what about if we could, what if we could fix that? What if there was something we could do with it? So let's take our broken docx file, the one we know doesn't work, and there's some very important components that go into this file that you may or may not have noticed. Look at this, word/document.xml. Doesn't that kind of look like a folder, a file path? Word being the folder, document.xml being the file. Where did we see this? We saw it in here. Look, Word, document.xml. If we were to go down the file, and this thing is so damaged, I don't know if we're even going to see anymore. Okay, here's another one. Word theme, theme1.xml. In a working file, Word theme, theme1.xml. You see how that works? But a lot of the stuff is, because this is broken, we're missing so much of that, which is why it doesn't actually open. Well, what if we could massage this a little bit to make it look better for our client? Remember, header information is header information. It's got to be the same across all platforms, or the computer's not going to know how to open all of these different files. So how about if we took a known good? Now, I know that this file here works. I know that that's a good file. I'm not going to use the components of this to rebuild my broken file, because you're going to sit there and say, well, yeah, one was made from the other one. Of course it was going to work. Let's take an unrelated one. Let's take this file here. We know it's a working file, nothing wrong with it, but it's definitely not this file. Okay, you see they're two different files. Let's take this completely unrelated file. Let's throw this in a Hex Editor. Wow, look at the difference here. Now we know that we're missing in our broken file everything before this word/document.xml. I don't know how much we're missing, but I know we're missing stuff. So the first thing I'm going to do is I'm going to clean this up a little bit. I'm going to get rid of all of this garbage so that word/document.xml is what I'm starting with. I'm starting with a clean place. It's like a broken wire. I've just spliced the wire and cleaned the one end. Now let me go get the other end. So I'm going to look through this file, and I'm going to try to find that word/document.xml. See, now we see some stuff here, but that's not quite the same. This would be easy to make that mistake, but it's not exactly the same. Remember, when we're talking about syntax, close isn't good enough. Okay, now we see some more. Word/document.xml. That's what I want. I want everything in front of that. So I'm going to sweep it. I'm going to go and I'm going to grab all of this stuff. How much information did I just sweep? 2,340 bytes. So I'm going to copy this, Control-C. I'm going to go back over here, and I'm going to put 2,340 bytes of space in front there. And then I'm going to paste, Control-V, the stuff I carved from the other file. So you can see this is the old busted file up to here. And before that, this is all the stuff I just pasted in from the known good file. Let's save that out. Let's go to our results folder. And let's see what happens. Man, no love, no love. But wait a minute. Remember what happened the last time. We clicked OK, It offered to see what it could do for us. So let's say yes. Boom. Now we have data. Is this pretty? Well, it's the way the content was laid out. It's not a fully functional Word file. If we close it and we go back, I don't know, let's save that. Let's see what happens. Let's just throw it on our desktop. It's easy to find. Will it open from here? Look at that, it repaired itself. How cool is that? So we did enough here to enable us to be able to open it as a Word document and then see the content as it was intended to be seen. Is it possible that we're missing some of the document? Well, let's face it. If we go to the end of this, it ends like this. That is not normal. Let's look at a normal Word document. What does it look like? That's what the end of a normal Word document looks like. It's got all of this stuff. That was what was causing our previous file to not open properly, even though the data was there. So I hope that what you've seen up to this point shows you that just because the file doesn't open doesn't mean there's nothing there to get. Now, a couple of things that I want to add that I'll wrap up with here. If you change this file, the broken file, to zip, and it doesn't open because the zip file is so broken, or because you're using WinZip or something like that, I would first recommend trying 7-zip. If 7-zip won't even open it, then grab up a file called zip repair. And let me just throw that up on the screen here. So there's the URL for zip repair. Oh. So disk internals /download/zip_repair.exe. And download it from there. Great little tool. Will allow you to fix this zip file if it can be fixed. And we've had great success with that too. We take the zip file, dump it into zip repair, let it do its hocus pocus. It will push out a new repaired zip file. And we've had unbelievable success with that new repaired zip file opening so that we can now go in and see the contents that we wouldn't have otherwise seen. Last thing I want to leave you with, because if you haven't thought of it, you'll probably think of it after the fact and you'll go, oh man, he sold us a bill of goods. So what I want to say is, how do you search for this stuff? How do you find this stuff? Well, in unallocated file space, if you're looking for something that you know is was in an Office document of some kind, you can actually run searches on Word/document.xml. There's only one place that's showing up, and that's in a Word document. If you wanted to do a spreadsheet, for example, this wouldn't be Word/document.xml. It would be Excel/workbook.xml. Now, I could throw up a chart, but I'm going to leave you with some homework instead. Do it yourself. Open up an Excel spreadsheet, a .xlsx in a Hex Editor, and look and see what these different things are. And then change the file extension of that spreadsheet to zip. Open it up as a zip file and look at all of the pieces inside and see how they correlate with what you're seeing in the actual hex of the file. You can do string searches on these. Why is this cool? Now you're not looking at through 20,000 Word documents. You are now focusing in on the stuff that matters to you. So that's about all I have. If you need to get a hold of me, there's my details from the slide deck. Just wanted to add that in June, great conference coming up in Vancouver with some digital forensics, a course being taught by, I believe, Heather Mahalik is teaching that one. Fantastic SANS instructor. There's some other courses being taught there. And folks never forget about the community side of the house. We usually know about the SANS conferences, but there's also community SANS, which is a lot smaller. It's only one class. It's not a bunch of classes. The class sizes are a lot smaller, a lot more personal, and are usually what's offered in the smaller markets where a conference couldn't be held. So just a little plug for community SANS. Again, my tombstone information, and I'm happy to take any questions if anybody's got some.
All right, thanks for that great presentation. This first item or two items came in about 30 minutes ago, and I'm not sure if I should have broken in. They look more like a tip to you. It says Canon's proprietary format is .dpp, or if you've been using it for a long time, .crw.
And I am familiar with CRW specifically, and I've seen that. There are viewers for that, but then if you look at any of these digital cameras, and that was just one example I used, it, you know, you can use those same techniques basically for any type of file. But you know, CR2, any of the other raw file formats that you're getting from photos, from cameras, nothing changes. When you open them up in a Hex Editor, the vast majority of them are going to look exactly like what you just saw. And all you have to do is go in there and find those components and expose them to what the computer's looking for, and they will open.
All right, thanks. The next question is, if you have spliced together pieces from other files, how can you use these composite files as evidence?
I love that. Oh, that's a fantastic question, and I get that very often. Here's the and we do a lot of court work, both criminal and civil. We've done testifying on both sides of the house. And I will tell you this. First of all, you have not changed the relevant evidence. You have not changed the content. I didn't change the verbiage in that spreadsheet at all. I didn't make that file, the wire transfer information stuff. I didn't change the content. You've still got the data. What I changed was how to get it to the courtroom so you could see it. In other words, I found some busted tools on the ground. I picked the tools up and I put them in a new toolbox and I brought them into the courtroom. Somebody's not going to make the argument, well, that's not the same toolbox those tools came in, so you can't use them as evidence. Well, yes, I can. I never changed the tools. I changed how I'm showing them to you. Now, I'm normally the kind of guy that says, it is not your job as a forensic expert to educate the other side's forensic expert. Remember that. You give them the raw file. You say, okay, well, don't take my word for it. Here's the raw file that I worked with. You can go see for yourself that this evidence is in there. All I've done is tweaked it so that you can see it on the screen. I haven't altered the evidence in any way. And if they can't figure out how to open it up, that's even better, because now I will show them on a big screen in a courtroom how we opened it up, and they can see click by click that we're not altering or introducing any more relevant information. That does two things. It makes me look really, really smart, makes the other expert look really, really dumb. Now who do you think the trier of fact is going to believe?
All right, thank you. That's all the questions we've had submitted. Do you have any closing thoughts?
Just that the slide deck is up there. You're welcome to contact me anytime if you have any questions, tips, pointers. If somebody's sitting there watching this and saying, Kev, I got a great idea for you, an easier way, or something else, that's how we learn. Either blog it out, send it to me privately, and I'll tweet it out. We're all in this big old cesspool together, so let's help each other out. And thank you all for joining in.
All right. Well, thank you so much, Kevin, for your great presentation, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.